Hey, what's going on? I shrunk myself on the size of a little piece of grass. It's nice and cool down here. Okay, enough with the corniness. Moving on to the worst jokes yet. Just two of them today. Which rock group has four guys who can't sing and play instruments? A rock group that has four guys who can't sing and play instruments. I'd say this rock group is pretty famous. What do Alexander the Great and Winnie the Pooh have in common? See you at the end of the video for those answers. All right, lesson 95, flying through them. Hopefully you're still feel like you're keeping up and can make sense of it. So it is, today we're talking about slant height of pyramids and cones. And if you remember last time, I had that cone that we were talking about the volume. I dumped it over to our friend the plant over there. So today I have another visualization of a cone here. And what's interesting is I can see this three-dimensional. You guys can't because you're watching it on a video. So what you see is actually what you need to see, whereas if it was 3D, you could, that would be cooler maybe. So what we're figuring out today is if I set this on wherever, right here, and that doesn't really work. If I set it on my hand, grab a tape measure, measure from here to the top of this thing, I can figure out the height of it. I grab a tape measure and measure the base of it. But what about along the side here, right? So this side right here. Now you realize that technically if your screen that you're watching on is life size, you can just slap a ruler on your screen and you can figure out the slant height. And there's a way to do this. As you can see back here, we'll figure that out. So just if you know the information, the base, base and the height, how can you figure out slant height? And keep in mind that, like I said, what you see is all that you need to see when you're figuring out slant height of a cone or a pyramid for that matter. And I'll just show you what I mean by that here. So this is a 3D visualization, supposedly, of a cone. Base is 10, height is 12. So if I took this thing and just chopped it right down the center, I took a utility knife and just right down the center, and you could see the inside core, kind of like you take a massive jawbreaker, chop it in half, hit it with a hammer, and it breaks in half nicely. This cone would look like this, roughly. A bottom of 10 centimeters, a slant height, or not a slant height, a height of 12 centimeters. So if you take the very top, so how in the world are you going to figure this out? Well, what you need to do is go from the very top and draw, go straight down. This should be centered, it's not. So on either side, you have 10 centimeters. That means on either side of this line, it should be 5 and 5. And you know the height is 12. So if you took this thing, I'm just going to pull it apart even further. What is this right here? It's a right triangle, which means you can use the Pythagorean theorem, and you have a height of 12, a base of 5, a plus b equals c. So a squared plus b squared equals c squared. A squared is 5 squared is 25. 12 squared is 144 equals c squared. 144 plus 25, you have 169 equals c squared, square root, that is 13. C is equal to 13. And if you remember just from a couple lessons ago, this could be positive or negative 13. You're not going to have a negative 13 slant height. But slant height is 13 centimeters for that. There you go. So that's what you're going to do. You're pretty much just going to take the base and pretty much look at the cross section. And the line is going to come down right in the middle. It's going to split your base in half. So it's going to go, and your height is going to be the vertical. You have a base, height, and then you need to figure out your slant height. And it's going to be a 90 degree because it's a straight line coming from the top. So that was example 1. I'm just going to jump right into the practice set. And here's one hint for you. Whenever you figure out the slant height, if you would loose this hinge here and push this line straight with this line, the slant height's going to be longer. It's kind of like a basic principle. If you're atop the sliding board and you fall straight down, did you go further than if you would have sat on the slide and just rode it down? No, because the whole point of a slide or an incline is to spread the force it takes to get up or down and spread that out over a longer plane. So if you go from this point and you go down to here, whereas if you're up at this point and take it the whole way down to here, you went a much longer distance. So the slant height is always going to be more than the height. And we'll figure that out. So practice set A says, describe the difference between the height of a cone and its slant height. And that is exactly what I just did there. Its height is from the bottom to the top, straight up. It's not measured on an angle at all. It's the slant side of it. What is that height? That's what it is. And B, same thing. The slant height of the pyramid is longer, shorter, or the same to the height. The slant height is longer. Always will be. C and D, we're going to figure out the slant height here. You have a cone and a pyramid, and we'll start with C here. So if you take this pyramid and cut it in half, you're going to have something that goes from the top, and it has a base. You go from the top to both corners. You're going to be like, whoa, 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 that's exactly like a cone. You're right. And a cone and a pyramid are going to look the same if you look at them two-dimensionally. If you just chop them in half, they're going to have the same. If their height is the same and their base is the same, then you're going to have the same cross. When you chop it in half, it's called a cross section. You're going to have the same cross section. So that's why these two work together as well. Because you can take a cone or a pyramid, chop it in half, and it's going to look like that. A cone's typically going to be much pointier, but if you can't see it three-dimensionally, then it should look the same for that. All right, so C and D. C, you have a base of 8 and a height of 8. Just going to put inches with the measurements. And the cone, you have a base of 4, height of 6. I have it upside down, so sorry about that. Okay. So straight line, because you want to make a right triangle. Straight down through. The height is 8. What's the base? The base is 8 from here to here, but we're only looking at half of that, so it's 4. So what is the slant height? You have A plus B equals C. Go ahead and figure that out. A squared plus B squared equals C squared. 4 squared is 16, plus 8 squared is 64 equals C squared. That is 64 plus 16, so we get 80. 80 equals C squared. Obviously, C squared equals 80, square root both sides. C is equal to what? So what is 80 simplified? Boy, this might be tough. So if I go 8 and 10, prime factor this, 2, 4, 2, 5. Okay. So this is the prime factorization of it. So here's a group of 2, pull 2 times 2 is 4, so the square root of 4 is 2. Square root of 4 is 2, and what's left inside is 5. So 2 times the square root of, which this cancels out to 4. The slant height is 4 times the square root of 5 there for that one. That's for C. Then for this one, same deal. Draw a line down. The base is 2. The height is 6. Again, the base is 2 because it's half of the original base, which is 4. So 2 squared plus 6 squared equals C squared. 4 plus 36 equals C squared. 40 equals C squared. This prime factor down is going to be 4, 10, 2, 2. So I already know that the square root of 4 is 2. That's going to go outside. And the square root of 10, that doesn't simplify any further. So 2 times the square root of 5 is equal to C. That is your answer for that. So for a bunch of these, that's what's going to happen there. And the way that works is what they'll often get you to do is probably round to the closest answer, because that doesn't actually help you out in real life. 2 times the square root of 5, it's like, well, what is that actually? So you'll actually probably need to figure it out and round to the nearest, who knows, half inch or tenth for it. Okay, that is it for that. Yeah, the past couple lessons have been pretty simple. So you will have a test on Monday, I believe it is, after you have this video done. All right, answers to the jokes. Which rock group has 4 guys who can't sing or play instruments? Well, the same rock group that they don't move, they're just carved into it. Mount Rushmore. Mount Rushmore has 4 guys who can't sing or play instruments. What do Alexander the Great and Winnie the Pooh have in common? They have one thing in common, and that is they have the same middle name. All right, see ya.